Sun and the 8 recognized planets that form our solar system. Jupiter, the grandest of all the Sun's planets. A gas giant so large every other planet could easily fit inside its vast bulk. Jupiter has 67 moons, 4 of them being large terrestrial moons. Jupiter is a virtual mini-solar system within the Sun's own solar system. A new theory suggests Jupiter may once have been a minor star in its own right, originally locked in a binary-like relationship with the Sun, with only the small planet Mercury present at that time amongst the other 7 planets that we see in the solar system today. This theory suggests that before the arrival and capture of at least 5 other alien planets, Jupiter orbited the Sun as a brown dwarf star, its position much closer into the Sun than it is today, in an orbit that placed it well within the Sun's habitable zone, and made possible the idea that at least 3 of Jupiter's current ice moons may have once been warm liquid water worlds, spectacularly conducive to the existence of life as we know it. As outlandish as this theory sounds to mainstream scientific thinking, the idea that Jupiter and its neighboring gas giant Saturn may be failed stars is not new. More than a few scientists have speculated that both planets share similar characteristics with brown dwarf stars, a class of substellar object that is believed to have not accumulated enough mass in its core to spark the nuclear fusion reaction supposedly needed to transform them into stars like our Sun, or so the theory goes. Yet Jupiter, and Saturn for that matter, both display undeniable star-like qualities not expected of planets. Both radiate more energy than they receive from the Sun. Jupiter displays intense aurora activity at both poles, as does Saturn. Jupiter is warmer at its poles than at its equator, as is Saturn. Jupiter emits X-rays and radio waves, a trait of regular stars and brown dwarf stars. Saturn's rings have been seen to fairly crackle with electrical activity on occasion, and both planets are very fast rotators, like the Sun. All this suggests that both Jupiter and Saturn share more in common with the formation of brown dwarf stars than they do with the accepted model of planetary formation, which claims all planets are accreted fragments of inert dust and gases found in a star's primordial circumstellar disk. In fact, so unexpectedly star-like are these 2 planets that, on closer inspection, their physical and dynamic compositions are obviously at odds with the accretion disk model, a model that mainstream science says is responsible for the diverse and oddly different physical makeups of the 8 known planets that currently orbit the Sun. A comparison between Jupiter and a brown dwarf star can serve to illustrate the feasibility of such an assessment, that is, that Jupiter may have started out life as a brown dwarf, and that this brown dwarf may have enjoyed a much closer and warmer relationship to the Sun in times past. Brown dwarf stars are difficult objects for scientists to classify. Being much cooler than main sequence stars like our Sun, they are hard to detect in the outer reaches of space when using standard optical astronomy equipment. To the naked eye, a brown dwarf star does not look brown at all. In fact, it will most likely appear as a cool red or glowing magenta-colored body due to the spectrum of light it produces, and be enveloped with a turbulent, dense, gaseous atmosphere very similar to a gas giant planet. The sizes of brown dwarf stars also pose a problem to many scientists. There is debate as to when an object stops being a gas giant planet and becomes a brown dwarf star. A contributing factor to this problem is the confusion often generated by mistaking mass for volume. A brown dwarf star may appear to be roughly the size of the planet Jupiter, but hold much more mass or material, while on the other hand, a different brown dwarf star may appear to be hugely larger or more voluminous than a planet like Jupiter, but be only the same size in terms of its material mass. A solution to this problem can be illustrated by the size of Jupiter's own intrinsic magnetosphere, which is the most powerful within the solar system. So large is Jupiter's magnetosphere that if it was rendered as an opaque glowing object in our night sky, it would appear to us to be the size of our full moon. Jupiter's magnetosphere is, of course, transparent, an electrical consequence of its position within the Sun's even more massive magnetosphere, commonly called the heliosphere. However, if Jupiter were placed outside of the influence of the Sun's heliosphere, that is, into the reaches of interstellar space, where most free-floating brown dwarf stars are found, its magnetosphere would most likely take on more opaque properties, especially when spotted by optical telescopes. The effect would be to massively increase the visible size of Jupiter without increasing its mass. Probably the most startling effect of this hypothetical scenario is that Jupiter's 4 major rocky moons, Io, Europa, Ganymede and Callisto, would all be optically hidden inside this opaquely glowing magnetosphere. Effectively, if Jupiter's energy output was scaled up to that of a brown dwarf star, then its moons would essentially take on the status of being planets, planets that are encapsulated inside this cocoon-like bubble that would optically hide them from the greater cosmos. That brown dwarf stars might have their own planets is a concept contradicted by modern scientific models for planetary formation. Theoretically, there is simply not enough material or mass in a brown dwarf star's circumstellar disk to allow for planetary formation by accretion. That is according to current thinking. Yet, in a sensational and recent development, 3 Earth-like planets have been found orbiting the star TRAPPIST-1 some 40 light-years away. As already noted, because most brown dwarf stars glow in the cooler spectrum, they are very difficult to spot by optical means. The use of radio and infrared astronomy techniques are better suited to spotting brown dwarfs, but the powerful magnetospheres surrounding these objects can disguise their true size and mass, and may be hiding many terrestrial-like moons from observers. According to the electric universe model, it is most likely that a plasma bubble or a plasma sheath will form around the magnetosphere of an interstellar brown dwarf star, making it even more difficult to assess its actual size and mass, and also adding to the opaqueness surrounding such an object and any moons orbiting it. Because the electric universe model accepts the existence of electrical fields in space, it is perfectly feasible that plasma, a fourth state of matter that makes up over 95% of the visible universe, will form a protective sheath around any electrically charged free-floating object in space. This protective plasma sheath will take on variable opaque properties when electrically excited by the divergences in interstellar electrical fields, and this will add to the visible size of the object it is surrounding. This is in accordance with Irving Langmuir's discoveries in the electrical sciences and the nature of plasma, and it helps explain the observable variances between the sizes and masses of brown dwarf stars. According to electric universe principles, we actually see this effect in action when lesser electrically charged comets enter into the Sun's own stronger electrical field from the depths of space, and begin to glow brightly while seemingly massively increasing in size. Mainstream science outrightly rejects this and claims this is the effect of sublimating ice from the comet's surface as the Sun's light heats it up. However, electric universe theory points to cometary fireworks as being electrical in nature, as the comet's overwhelmed electrical field reacts to the Sun's far stronger electrical output, the so-called solar wind. In short, the growing number of large brown dwarf stars and so-called rogue gas giants sighted in interstellar space are most likely plasma-sheathed objects with large, dense and fast-rotating cores at their centers, and possibly come complete with one or more moons orbiting those cores, but all hidden within the encapsulating plasma bubble. Again, if we were to render Jupiter's magnetosphere opaque, then all its own major moons would be hidden from us within this vast bubble. Jupiter, for all intents and purposes, would take on the look of any brown dwarf star known to exist today. A curious factor in the ongoing search for exosolar systems like our own is that we have yet to discover an alien solar system even remotely configured like our own. Surprisingly, to mainstream science, our solar system appears to be the odd one out, and current theories that demand the formation of gas giant planets at orbital distances matching our own gas giants are increasingly shown to be inaccurate with the discovery of so-called hot Jupiters. Hot Jupiters are gas giant planets with orbits far too close to their host stars to have been formed according to the accepted theories of planetary formation. But there are now so many of these hot Jupiters being discovered that it begs the question as to whether these theories are valid. It actually suggests that gas giant planets are more likely to be found either in close orbit or at much greater distances than accepted accretion theory allows. As we have also seen, the boundary between what is a gas giant planet and what is a brown dwarf star is somewhat blurred. So it is likely that some of these so-called hot Jupiters circling in close orbit to their host stars may, in fact, be brown dwarf stars. So, if Jupiter had started out life as a brown dwarf star, is there a case to make that it would have likely enjoyed a closer orbital relationship to the Sun in its distant past than it does today? In order to explore this question further, one is asked to consider that a closer orbit for Jupiter in the distant past must surely call for the absence of many of the other planets that we now see sharing the solar system with Jupiter, including Earth. This is probably the most outlandish aspect to this new theory suggesting Jupiter's past as a brown dwarf star. So is there any evidence to support the absence of the other planets at the time Jupiter is postulated to have been locked in a binary relationship with the Sun as a brown dwarf star? The current axial tilts of the planets orbiting the Sun today may offer an answer to this question. The solar system as we know it comprises 8 planets. 4 are rocky terrestrial bodies, with the remaining 4 being gas giants. Many of these planets have singular or collections of moons orbiting them. Of the 8 recognized planets, only 2 share an axial tilt in common with the Sun, that is, an upright celestial north-south orientation. They are the small close-in planet Mercury and the gas giant Jupiter. 4 of the planets, Saturn, Neptune, Earth and Mars, all share axial tilts of roughly between 23 degrees and 28 degrees, something that is completely at odds with the accepted accretion disk theory of planetary formation, and indicates a separate origin for these planets to that of Jupiter and Mercury. One planet, Uranus, is oddly placed on its side with a tilt that points along its orbital path. This may indicate a past catastrophic event that knocked the gas giant on its side, or it may also indicate a separate origin to the other planets. Its bizarre orientation is also at odds with the accepted mainstream accretion disk theory. Most peculiar of the planets is Venus, an exceedingly hot planet that seems to have flipped on its axis and now actually spins in a retrograde fashion compared to the other planets. This once again is completely at odds with accretion disk theory. The broiling hot nature of Venus's surface indicates that it is a recently birthed planet compared to the other terrestrial planets, and not the result of the so-called runaway greenhouse theory. The point being stressed here, though, is that the Sun's current collection of planets does not necessarily conform to the accretion disk theory. Only two planets, Mercury and Jupiter, share a native axial tilt with the Sun. The remaining other planets do not. A startling question arises. Is it possible that our solar system is, in fact, a collection of original native planets catastrophically displaced by the later arrival of a group of captured rogue planets? Is there possibly a period in our solar system's ancient history when the planets Saturn, Neptune, Uranus, Mars, Venus, and even Earth were nowhere to be seen, and Jupiter reigned supreme with the Sun? In observing other solar systems, we can see that gas giants often orbit closely to their host star, and that many of these so-called hot Jupiters may be brown dwarf stars, complete with their own collections of moons. If our solar system originally began with only Jupiter and Mercury as its original native planets, evidenced by their axial tilts being the same as the Sun's, then it would not be amiss to suggest that Jupiter may have shared the same orbital characteristics of many gas giant exoplanets being discovered today. The problem here is that many of these hot Jupiters are too close to their suns to suggest they or their moons might be habitable. They are simply too hot. However, there are a few gas giant exoplanets that have been discovered orbiting their host star in what is called the habitable zone, and these give hope to the theory that their moons may support the needed attributes for the emergence of life as we know it. Should closer inspection of these habitable zone gas giants prove them to be brown dwarf stars, that is something entirely possible given the blurred lines between gas giants and brown dwarfs, then the possibility of liquid water moons becomes enticingly likely. Brown dwarf stars are known carriers of water, sometimes copious amounts of water, so it is entirely likely that any moons orbiting them will accumulate a portion of this water. Such moons are likely to be ice moons due to the weak heat being emitted by their host brown dwarf. Ice moons like those we see today orbiting around Jupiter and Saturn. But if a brown dwarf star with water-saturated moons were ever to exist within the habitable zone of a main sequence star like our own Sun, then those moons would most likely have liquid water on their surfaces. In a hypothetical solar system comprising of only Mercury and Jupiter, the possibility that Jupiter's orbit may have been in the desired habitable zone is buttressed by the existence of such similar gas giant exosolar systems. If we assume also that Jupiter's current star-like characteristics make it a contender for having once been a brown dwarf, then it is entirely plausible that at least one of its moons had all the necessary ingredients for the supporting of life as we know it. That moon is called Ganymede. Ganymede is Jupiter's largest moon. It is, in fact, the largest moon in the solar system, almost being the size of Mars. The amount of water on Ganymede dwarfs the amount of water on Earth. It is a moon with a global ocean, an ocean that has turned to ice due to Jupiter's current far-out orbit beyond the solar system's frost line. But what makes Ganymede particularly interesting are the two things it has that no other terrestrial body in the solar system has, with the exception of Earth. Ganymede has oxygen, and it has an intrinsic magnetosphere. The second of these characteristics, its intrinsic magnetosphere, is an essential ingredient in protecting any life that may have existed on Ganymede due to the intense brown dwarf star-like radiation put out by Jupiter even to this day. Life on Earth as we know it is superbly protected from harmful cosmic and solar radiation by its thick water and oxygen atmosphere and strong intrinsic magnetosphere. Only Ganymede, of all the known terrestrial planets and moons in our current solar system, also has these two essential factors for supporting life as we know it. Today, Ganymede's surface oxygen is more an exosphere than an atmosphere. too thin to provide the kind of protection Earth's own oxygen does today, but its natively induced magnetosphere is plenty powerful enough to vastly reduce the harmful effects of Jupiter's high radiation output compared to the other Jovian moons. Europa, another possible source for alien life locked away in the depths of its own ice-covered ocean, suffers a lack of atmospheric oxygen. The same applies to the moons Io and Callisto. Io is a volcanic moon with no water, while Callisto, which has water and is safely outside of Jupiter's intense radiation belt, has no intrinsic magnetosphere to counter cosmic and solar radiation on its surface. Callisto would also be too far out to benefit from Jupiter's warming if that planet were a brown dwarf. Only Ganymede has all the ingredients making it a contender for supporting life as we know it. Unfortunately, it is today too cold to support life on its icy surface. But what of the past? What of the idea that Jupiter may have once been a warm, glowing brown dwarf star in a much closer orbit to the Sun than it is today? Under such hypothetical circumstances, Ganymede becomes the best contender beyond Earth itself for the sustaining of life as we know it. Ganymede, with its global ocean, would have been a literal water world, safely preserved inside its own intrinsic magnetosphere, its atmosphere thicker and much more richly endowed with life-giving oxygen, and warmed by the twin heat of the Sun and Jupiter. Dubbed the antique solar system by the authors of Cosmos and Collision, this configuration involving the life-inducing and sustaining properties of the Sun and its binary brown dwarf Jupiter, along with the liquid water world of Ganymede, may have existed in harmony for untold aeons. That is, until the arrival of another rogue brown dwarf star with its own set of alien planets, an event that would disrupt and catastrophically rearrange the solar system into the diverse and contradictory collection of planets we see today. If this was, in fact, our solar system's past, then it strongly suggests that the search for life beyond Earth should start with the Jovian moon we call Ganymede. An important element to the Ganymede hypothesis is the idea that solar systems are formed from the polar jets of what we call Herbig Haro objects, and not out of the circumstellar disks of dust and gases surrounding many stars, as accepted accretion theory insists. A Herbig Haro object is a category of axially-aligned celestial objects centered around young proto-stars that are seen to be emitting vastly long polar-aligned jets of plasma along their axes of spin. Along the length of these jets can be seen what are believed to be beads or bubbles of plasma. While it is currently not known exactly what might be inside these so-called beads, their sizes and nature indicate to proponents of the electric universe model that these beads might be areas of intense electromagnetic activity, and therefore possible areas for planetary formation. Mainstream science claims a Herbig Haro object's polar-aligned jets are simply pressure-induced hot gases being spurted out into space by their protostar in the same way a garden hose spurts out a stream of water. However, the garden hose analogy fails when one realizes that gases under pressure dissipate almost instantaneously in the near vacuum of space, and simply cannot maintain the physical integrity as seen in these vastly long streaming jets that typify Herbig Haro Objects. According to the electric universe model, only the filamentary nature of electrically charged plasma, as seen in countless color-enhanced images of space, can account for the nature of the so-called gas jets we see being emitted from the polar regions of protostars that make up Herbig Haro objects. This is because these so-called jets are, in reality, powerful Birkeland currents, the plasma-conducted currents of electrical energy that permeate space and which were first discovered over 100 years ago by the Norwegian scientist Christian Birkeland. According to electric universe principles, the protostar seen at the center of Herbig Haro objects forms as the result of a Z-pinch taking place along an existing Birkeland current. This is actually a type of short-circuiting that is taking place, and not the result of gases imploding under their own weight to trigger nuclear fusion reactions. Most stars can be seen clearly placed along the filamentary strings of plasma that show up in enhanced space images. Subsequently, stars are to be understood as electrostatic phenomena according to the electric universe model, and a Birkeland current that undergoes a Z-pinch will produce this kind of effect along with powerfully attractive magnetic fields capable of sucking vast amounts of heavy elements into its core. The subsequent plasma beads seen forming further along both the north and south stretches of this Birkeland current are simply lesser Z-pinches, but are still areas capable of generating intense magnetic fields, and therefore able to also concentrate heavy element matter into their centers to form the kind of protocores needed to form planets and brown dwarf stars. As stated earlier, while it is not currently known what is inside these plasma beads, the authors of Cosmos in Collision believe protoplanets and proto-brown dwarfs can and are being created by this process. At some stage in the Herbig Haro object's life, the highly active Birkeland current that has formed the central protostar and the series of plasma beads along its length will break. When this happens, the protostar is electrically severed from the plasma beads seen along the length of its jets, and severed from any object that may have formed inside these plasma beads. The jets will disappear, effectively leaving a series of independent celestial objects strung out from each other along their original axis of spin. That is, a series of axially aligned celestial objects that will range from the main protostar at the center of the Herbig Haro object to possible brown dwarfs, gas giant planets, and even terrestrial planetary bodies. Because all these bodies originally shared the same axial spin and direction of motion while joined by an active Birkeland current, they will continue to proceed through space in roughly the same direction, though at different speeds and increasingly different axial tilts. The protostar at the center of the Herbig Haro object will now most likely travel fastest along its original celestial northerly course, where it will eventually catch up to any planetary body or brown dwarf that may have formed in the plasma beads of its northern jet. Upon catching up to these bodies, the protostar will force these planets or brown dwarfs into an orbital relationship with itself, something that may slow its northerly progress in the process. Any southerly planets or brown dwarfs formed in the protostar's southern plasma jet will, though severed from their protostar, also continue a northerly journey in the nominal slipstream of the protostar and, at a later date, also be captured by the protostar as they catch up to it, thanks to the protostar having been slowed by its previous capture of the northern bodies. In this way, a protostar formed at the center of a Herbig Haro object is destined to collect to itself any celestial bodies previously formed by Z-pinches in its polar jets. The process of collecting these disparate bodies will be catastrophic and induce highly destructive changes in the electrical status of any planets or brown dwarf stars that form as a part of a Herbig Haro object. Eventually, however, the process will see all the involved bodies electrically equalize and settle into a stable orbital configuration. Eventually. In the case of the Ganymede hypothesis, our Sun is postulated to have started life as a proto-star, or proto-sun, at the center of its own Herbig Haro object. Strung out along the powerful Birkeland current that formed our proto-sun were a range of planets and brown dwarf stars. The planets Jupiter and Mercury, including Jupiter's moons, formed in the plasma beads of the proto-sun's northern jet, while the planets Saturn, Uranus, Neptune, Mars and Earth formed in the plasma beads of the proto-sun's southern jet. It is most likely that at this time both the planets Jupiter and Saturn originally formed as brown dwarf stars, complete with their own collection of moons and planets. At some point, the proto-sun's powerful Birkeland current failed and the proto-sun was electrically severed from its future planets. Continuing along its northern course, the proto-sun eventually captured and collected the planet Mercury, and then the brown dwarf Jupiter along with Jupiter's 4 moons. This became the basis of the antique solar system as discussed by the authors of Cosmos and Collision, in which Jupiter's moons may have once been liquid water worlds highly conducive to life as we know it. At a much later date, the gas giant planet now known as Uranus caught up to the proto-sun's antique solar system and was catastrophically captured by the Sun, the result being Uranus knocked on its side and left in the bizarre orientation we see it in today. At an even much later date, the brown dwarf Saturn, along with the planets Neptune to its north and Mars and Earth to its south, caught up to the Sun, and via a series of catastrophic encounters was also eventually captured. This highly destructive epoch in our solar system's history saw a catastrophic rearrangement of all planets involved in this process as they electrically discharged and equalized with the Sun, and even saw the birth of a new planet that would later be called Venus, as the brown dwarf Saturn fissioned spectacularly and ejected a piece of its core under intense electrical stress from the Sun's much more powerful electrical field. These catastrophic events are the origins of world mythology, witnessed by humanity and recorded for posterity. Over time, both Jupiter and Saturn were reduced to gas giant status and pushed to the outer realms of the Sun's new solar system, while the terrestrial planets collected at much closer orbits, with the Earth finding itself fortuitously placed in the Sun's habitable zone, where it is today.